let's see, let's find the area of this figure, this regular polygon. Let's see, some things I need to, I have a picture, but I'd like to add to this picture. First, I'd like to figure out what the triangles are going to look like that I need to find the areas of. And these are terrible triangles, but they're triangles nonetheless. Let's see, what do I know? I know the side length is 6 inches. I know the number of sides, because I can count. 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So which area formula should I use? It's not clear, although I do know a side. So if I know a side, that means I only need to know the apothem. So I think due to that, I'll find the apothem length of this, which means I need to figure out the distance from the center to the side at a right angle. Just like in the previous example, I'm going to think of this, I'm going to draw kind of a smaller picture here. I need to figure out what this apothem length is. It means I need to know what the central angle is. The central angle should be 360 divided by how many sides there are. There are 9, which makes the central angle 40 degrees. Or maybe better yet, if I look at just this right triangle, so I can use SOHCAHTOA, I think that means that these parts are each 3. The apothem is still the apothem. And this new angle should be, is the central angle split in half. It's half of 40 is 20 degrees. So if I want to find A, I know the 20-degree angle, I know the opposite and adjacent. Opposite and adjacent's the OA of TOA in SOHCAHTOA. So I think the tangent of 20 degrees is equal to opposite over adjacent. Cross multiply, 3 is equal to A times the tangent of 20. Divide both sides by this tangent to get A by itself. And the apothem length is 3 over the tangent of 20 degrees, whatever that is. I'll calculate that on my graphing calculator shortly. I know the area. The area formula is 1/2 times the apothem length times the side length times the number of sides. This expression is the apothem length. And I know the side length is 6. And the number of sides is 9. So this is 1/2 times this 3 over tangent of 20 times the side length of 6 times the number of sides, which is 9. And on my calculator, that works out to be 0.5 times fraction of 3 divided by the tangent of 20 times 6 times 9, which is 222.546, or to the nearest tenth as before. The nearest tenth as before, that's 222.5 square inches. Our final example is this regular pentagon. In this regular pentagon, I know that the radius of this regular pentagon is 8. I know the apothem length is 6.5. And I want to find the area of this thing. You could use either formula, either the apothem side in number of sides formula, or the previous one we used in the previous problem here, the half times the radius squared times the sine of the including central angle times number of sides. It doesn't really matter which way you go. I think that the one involving the radius and the central angle is going to be easier to do because I already know A, and the central angle is much more easy to calculate than a side length there using trigonometry or Pythagorean theorem or whatever else we want to use. So I'm going to just calculate what one of these central angles is, and I'm going to use that second formula. And the central angle should be 360 divided by 1, 2, 3, 4, 5 triangles, which is 72 degrees. My area formula is 1/2 times the radius times itself times the sine of a central angle times the number of sides, and I know both of those things. It's 1/2 the radius of 8 times the sine of 72 degrees times the number of sides, which is 5. 0.5 times 8 squared times the sine of 72 degrees times 5 is 152.169, or to the nearest tenths place. So this is about 152.2 square units.